So in this question we're asked to sketch the graph of y equals x minus 3 all squared plus 1, and there's various conditions put in this. We have to show clearly the coordinates of the turning point and also the point of intersection with the y-axis. So to do this, let's explore graphs of this form in a more dynamic way. So here's a diagram showing us the graph of y equals x minus h all squared plus k, and at present h is 0, so it's just showing x squared plus k is 0 plus 0. So that's the graph y equals x squared. If we take a x, square it, 1 squared is 1, 2 squared is 4, or at a height of 4. Negative 1 times negative 1 is 1, negative 2 times negative 2 is 4. So we're seeing the values of x squared. So this is y equals x squared, typical parabola. Now let's have a look at the effect of subtracting a number from x. So let's move the value, there's the value h equals 1. You notice the graph, as I change the value of h from 0 to 1, the graph moves to the right. So we're now looking at x minus 1 all squared plus 0. Let's move the value we're subtracting up to 2, and again it's moved further to the right, to 3, to 4, to 5, and so on. And let's move the value of h back to 0. So when we subtract 1, 2, 3, 4, etc., the graph moves to the right. And then if we subtract negative 1, that's like adding 1 and adding 2. If we make the values of h negative, then it moves to the left. So there's x plus positive values in effect. So x minus 1 or 2 or 3, it moves to the right. X plus 1, 2 or 3, it moves to the left. Now what effect does adding a number at the end have? Well, at present k is 0. Let's add 1. So all the points on the graph have moved up 1. We're adding 2, we're adding 3. So the effect of adding a number at the end just moves the whole graph up by, in this case, k units, whatever k is. And if we subtract numbers and add negative 1, negative 2, and so on, then the graph just proceeds down parallel to the y-axis. So that's the effect of various changes to the minus number here and the plus number at the end. So let's go back to the question now that we've seen that. So let's get our axis drawn. There's our y-axis and there's our x-axis. Label them. And remember we had the graph y equals x squared, and when we subtracted positive numbers from that, the graph moved to the right. So it would move 3 units to the right, and then it would move up 1. So here is the final position of that graph, that parabola. Now certainly it's going to cross the y-axis quite high up here at this point here. So the coordinates of the turning point, that's this point here, 3 along, 1 up. That's 1 unit, that's 3 units. So the last thing we need to decide is how on earth do we find where this graph crosses the y-axis. Now the one thing we do know about the point, any point in the y-axis, is that its x coordinate is 0. So if we look at the equation of this red graph that we've drawn. To find where it crosses the y-axis, for y-axis intercept as it's sometimes called, we're going to set x equal to 0. So that means that y will be 0 minus 3 squared plus 1. So that's negative 3. 0 minus 3 is negative 3. To square that and add 1. Negative 3 times negative 3 is positive 9, plus 1 will give us 10. So this point up here is 0, 10, or is 10 on the y-axis. And that's a sketch. Now I'm thinking that's just a bit messy. Maybe in the exam, if you're working away and you make a bit of a mess of something like that, then we could redo the picture, make it look a bit clearer. So there's 3, 1, and it crosses at the point 10. That's x, that's y, and let's label this. This is a sketch of y equals x minus 3 all squared plus 1. So that's the title of our sketch. And there's the origin there.